Hi friends! Welcome to Math for Thursday, April 2nd, 2020. Today we're going to start with some fluency, counting our nickels, dimes, and pennies. Recall that a nickel is worth 5 cents, a penny is worth 1 cent, a dime is worth 10 cents. Which is worth the most? A dime. Which is worth the least? A penny. Looking at this chart, let's skip count to find how much money we have in total. Let's start with the dimes because the dimes have the most value. Point to the dime. 10, 20, 30, 40, 50. Let's find the nickels. Point to the nickels. 55, 60, 65, 70. And last, point to the pennies. 71, 72, 73, 74, 75, 76. Altogether, we have 76 cents. This is just like counting on a number line, but it's important to remember how much each is worth before you begin counting so that you don't make a mistake. If your brain works counting from pennies, then nickels, then dimes, that's great. If your brain works from dimes to nickels to pennies, that's great. Or if your brain just works by looking at the total and figuring it out in order, that's great. Whichever way you count money is wonderful, as long as you are sure that you are putting the value to each coin. Good job. Let's take a look at this review question. Bella is 30 inches long. Stella is 27 inches long. How much shorter is Stella than Bella? Before we even solve this, we need to figure out what this problem is asking. If it says that Bella is 30 inches long and Stella is 27 inches long, and it's asking how much shorter Stella is than Bella, what operation will we use? Will we add or will we subtract? We will subtract. Take a look at your options. A, 30 plus 27. Is that subtraction? No, so that is not our best answer. B, 27 plus 30. Is that subtraction? No, so that is not our best answer. C, 30 minus 27. Is that subtraction? Yes. Stella is 30 inches long. Bella is 30 inches long. Stella is 27 inches long. And we are trying to figure out how much shorter Stella is than Bella. So we would start with Bella, 30 inches. Take away Stella, 27 inches. C is our best answer. Time for a challenging application problem. Gemma is counting animals in the park. This problem has a lot of questions in it. We need to slow down. Let's start by labeling. Gemma is counting animals in the park. Great. She counts 16 robins. I am going to label that by saying 16R. 19 ducks. 19D. 17 squirrels. 17S. This way, I know the numbers that I am dealing with. Let's look back at the problem. She counts 16 robins and 19 ducks. And it asks how many more robins and ducks did she count than squirrels. So first, I need to take a look at my 16 and my 19. If I want to find out how many robins and ducks she counted, I would need to add. So I'll start with 16 and I'll add 19. This looks like a tricky problem, but I remember that 19 is close to 20. So instead, I'm going to add 16 plus 20, a friendly number. 6 plus 0 is 6. 1 plus 2 is 3. 19 is 1 less than 20. 1 less than 36 is 35. My brain recognized a friendly number was close by. If your brain wants to do the vertical way or model, that is okay too. Remember, we use strategies that make the most sense for us. So now, instead of 16 robins and 19 ducks, I'm going to say 35 R and D. The question now asks, how many more robins and ducks did Gemma count than squirrels? To solve this, I will need to subtract. So I'm going to subtract 35, which is my robins and ducks, take away 17, which is my squirrels. Let's solve this in a different way. Let's model. 35 is 1, 2, 3 tens, and 1, 2, 3, 4, 5 ones. 17 is 1 10 and 1, 2, 3, 4, 5, 6, 7 ones. Can I take 7 ones from 5 ones? No. 7 is more than 5. So what I'll need to do is I will need to regroup. I'm going to take 1 10 away and turn that 1 10 into 10 ones. Now I have 15 ones and 2 tens. I still have 35. Let's see if I can take 7 ones away from 15 ones. 1, 2, 3, 4, 5, 6, 7. I can. How many ones are left? 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 ones. Now I only have 2 tens. And remember, I already had 15 ones. How many tens do I take away? I take away 1 10. How many tens are left? 1. So the answer is that Gemma counted 18 more robins and ducks than she counted squirrels. This is a tricky application problem. It first asked us to add, and then it asked us to subtract. Be sure to read the problems carefully so that you can solve them the best way you know how. Let's take a look at a new graph. This graph is of animal habitats, just like yesterday's, but it looks a little different. Do you see at the top where it says legend/key? And each gray circle stands for one animal? That is how we know what each of those circles means. In the Arctic, there are 4 animals. In the woodland, there are 10 animals. And in the ocean, there are 6 animals. Let's see if we can use this graph to answer these questions. The first question asks, how many fewer ocean than woodland animals were classified? I see that there were 6 ocean animals classified and 10 woodland animals classified. Those two numbers are different. When I'm trying to find the difference, do I add or subtract? I subtract. 10 minus 6. 10 woodland, 6 ocean. Remember, if you can't do this quickly in your head, although you should be able to because of your fluency practice, you could always make a model. 10, take away 6 is 4. Let's take a look at the second question. How many fewer Arctic animals than woodland animals? We'll still start with 10 because that's the woodland. But now we're going to take away 4. 10 take away 4 is 6. Good work. Here's where it gets tricky. How many more ocean than Arctic animals were classified? Now we need to compare the number of ocean animals with the number of Arctic animals. Ocean is bigger, so we'll start with a 6, and we will take away 4. This should be easy to do in your head because you know your fluency problem so well. 6 take away 4 is 2. Good work. Let's take a look at the results of a survey that Miss Pridgeon's class took. What do you notice? I notice that there are animals, birds, mammals, reptiles, fish, with numbers below. The numbers must tell me how many of each animal Miss Pridgeon's class chose as their favorite. Let's take a look at the questions for this data. How many students prefer birds, reptiles, or fish? How many more students like mammals than reptiles? What is the difference between the number of students who like fish and the number of students who like birds? See if you can solve these problems on your own. This is a challenge, but it will help you with your application problems later. If you need any help, feel free to call, text, or email. I can't wait to see your answers.